Karibuni sana, my friends. Welcome back. Coach Data here, and today we're turning data into decisions with an absolutely incredible explainer. We are taking a digital journey right into the heart of Tanzania to crack the Daladala challenge, and we're doing it line by line. Okay, let's dive into this.
So, how exactly do we predict Daladala peak demand? Now, if you're not familiar, Daladalas are those iconic minibuses that are literally the lifeblood of transportation in Tanzania. They weave through these vibrant, busy streets, getting thousands of people where they need to go every single day. The mission for this ML challenge is pretty fascinating. We need to look at historical data and predict if a specific Daladala route is going to hit peak demand at a given hour on a given day in a specific city. No pressure, right?
Here's our safari itinerary for today's explainer. 1. Getting the tools ready. 2. Exploring the dataset. 3. Cleaning the data. 4. Building the ML model. And finally, 5. Generating that final submission.
All right, section 1, getting the tools ready, packing for the safari.
Think of this step exactly like packing your bag before heading out on a massive safari. You definitely wouldn't leave Dar es Salaam for the wild without your absolute essentials, right? Well, in data science, we pack our imports. First up, we've got Pandas, affectionately known as PD. It's basically a superpowered data table living right inside your code. Then there's NumPy, or NP. When you need to crunch millions, literally millions of numbers, NumPy does it in milliseconds. It's lightning fast. And finally, Yada Data Profiling, which is kind of our automated scout to survey the territory ahead.
Moving right along to section 2. Exploring the dataset. Loading the data.
So we're bringing in exactly 25,000 rows of data. Each row is a historical snapshot of one route in one city for one specific hour. But we gotta split this massive pile of info into train data and test data. Think of the training data as your study guide. It has the peak column. It's like having the exam questions with the correct answers right there so you can learn the patterns. The test data? Well, that's the actual final exam. No answers provided. The peak column is totally gone, and our algorithm is gonna have to figure it out completely on its own. Now remember that Yada Data Profiling tool we packed earlier? This thing is absolute magic. You run it, and boom, it automatically generates this gorgeous, interactive HTML report of your entire dataset. Instead of writing 50 lines of code to hunt down missing values or check if rain correlates with traffic, this tool handles the whole shebang in the background. It's exactly like getting a comprehensive doctor's report on your data without ever stepping foot in the hospital.
Okay, section 3. Cleaning the data. Pre-processing.
It is time to clean house. Because look, a machine learning model is only ever as good as the data you feed it. Feed it garbage, and it's going to enthusiastically hand you garbage right back. So let's strike down these problematic columns. First up, random_index 1 and 2, pure useless noise. Toss 'em. Next is noise factor. The competition creators actually put this in as a deliberate trap to trick your model. So yeah, we're throwing that right out. Then we have previous hour demand. This causes a massive headache called data leakage. It gives the model future info it wouldn't realistically have, which totally ruins its predictive power in the real world. Finally, average income index and is weekend. I mean, if the system already knows it's Saturday from the date, it absolutely doesn't need another column screaming that it's the weekend. Total redundancy.
Now, listen up, because this is a massive, absolutely crucial rule. You must drop the exact same columns from both your train and your test data. Why? Well, your model learns to look for a very specific shape during training. If it trains on 9 clean columns, and then your final test data suddenly hands it 11 columns, crash. The whole system will literally crash hard. Consistency here is non-negotiable.
And now for the really fun stuff. Section 4. Building the ML model. The star of the show.
This right here is where the actual machine learning happens. To build this predictive engine, we feed it features. These are basically our clues. We're using things like city, route type, hour of the day, rainfall, and fuel price. And every single one of these tells a unique story. Like, think about it. When rainfall goes up, nobody wants to walk outside in the pouring rain, right? So everyone rushes to the Daladalas. Or if fuel prices randomly spike, maybe fewer people drive their own cars, which directly shoots our peak bus demand straight up. But wait, here's the catch. Machines only speak math. They don't speak words. We can't just hand an equation the words Dar es Salaam, Arusha, and Mwanza. So we use a brilliant trick called one-hot encoding. We turn those cities into numbers. Dar becomes a column of 1, 0, 0. Arusha becomes 0, 1, 0. Just like that, we've seamlessly translated human text into mathematical language that the machine understands perfectly. For the algorithm itself, we're rolling with a random forest classifier.
But we gotta set some ground rules, or parameters. First, n estimators equals 5,000. It's like, if you wanted highly accurate weather advice, you wouldn't just ask one guy on the street, right? You'd ask 5,000 different people, or in our case, 5,000 individual decision trees to get a super reliable majority vote. Second, max depth is 6. This stops our trees from overcomplicating things and just memorizing the training data. We want them learning the actual concepts. And finally, random state equals 1, just to make sure we get the exact same results every single time we run the code.
Okay, here it is, model.fit. This is the magic moment. We hand over all 25,000 rows of our historical data. Our 5,000 trees instantly get to work, rapidly digging through and finding those deeply hidden patterns between the rain, the time of day, the specific cities. This is the exact moment the system finally figures out what really causes peak demand on these specific Tanzanian routes.
And then, the moment of truth. Model.predict. We hand our newly trained, highly tuned model the blank test exam, the real-world data with missing answers. Based on everything it just learned, it fills in the blanks, spitting out a massive array of zeros and ones as our final answers. A 1 means, yep, we predict a peak. A 0 means no peak.
We are almost there. Section 5. Generating the final submission, the finish line.
We've made it to the final leg of our safari, but we have to be super careful here because the competition platform is notoriously strict about formatting. If you don't follow the exact saving rules, you don't get a score, period. So we keep only the ID column and our new peak prediction column. We save it precisely as submission.csv. And most importantly, do not forget this, we set index to false. If you don't, Pandas naturally tries to add its own row numbers, and that will instantly trigger a frustrating format failure from the automated judges.
When that final block of code executes flawlessly, you get that beautiful message on the screen. Your submission was successfully saved. Hongarasana, congratulations! We literally just went from raw files and basic imports, all the way to a fully functioning machine learning pipeline predicting real-world transit demand.
But hey, keep in mind, this is just a baseline. It's literally just our starting point on the map. Out there on those busy streets, the Daladalas keep moving, and so must our learning. Every little tweak you make from here, whether that's engineering clever new features out of the date columns or fine-tuning those random force parameters, every single tweak is going to push your score higher and higher up that leaderboard.
So I'm going to leave you with a little something to chew on. We've seen exactly how to build a highly successful baseline model today. But what brilliant new feature are you going to engineer tomorrow to absolutely conquer that leaderboard?
The tools are in your hands now. Data is power. Learn it. See you next time.